Hello, welcome to the Vivid Brains. Welcome to the Vivid Brains. Today we are observing one of the JEE main question of 2022. The question goes like this. The number of distinct real roots of the equation. Let me read that equation. That is, you take it as the equation goes like this. X power 5 into, x power 7, x power 5 into x cube minus x square minus x cube minus x square minus x plus 1 plus x into 3x cube minus 4x square minus 2x plus 4 minus 1 is equal to 0. Okay, this is our equation. We have to find the identical roots of this whole equation. Understood? So whenever you want to find the, the roots of the given equation, generally what do? Generally, we are going to observe the coefficients, right? So if the sum of coefficients is 0, then what do you say? X is going to be 1. Then, x is going to be 1, right? X is going to be minus 1. Then factor, one of the factor is x plus 1. Like that we are writing. Okay? Yes. So can you write now? What do we write? Can you first let us multiply this, okay? X in x power 8, x power 5 into x cube, minus x power 7, minus x power 6, plus x power 5, plus 3x power 4, minus 4x cube, minus 2x square, plus 4x minus is equal to 0. Okay? Alright. Now you observe here. If you observe x power 8 and x power 7, x power 6 and x power 5. So one is less than that. So can we take any common? Because we need factor. We are factorizing, right? So we try to try to take out any common things. So let me take here x power 7 out of bracket. Then here x power 7 is left and x power 7 minus 1. Okay. Next, what I do is, here also I am going to take minus x power 5, and then x minus 1 is left. Okay. Now, if you observe in this case, 3x power 4 plus minus 4x cube. Okay. If you observe in this case, what do I write? You see, because I have to get x minus 1 again, right? So if I get x minus 1 in all the terms, I can take out that x minus 1. So we can easily get the factors at that time. That is by A. Okay. I have to get x minus 1. You already have 3x power 4. Okay. How do I write in order to get x minus 1 here? So can I go with, can I write this as 3x cube, 3x power 4, it's already there, minus 3x cube, right? So if I have, this is minus 3x cube, then I can take out x minus 1 common, right? You see, let me write one more step. You see, my plus 3x power 4 minus 4x cube means if I have minus 3x cube, then I can take 3x so that I will get x minus 1 as common, right? So if I split this minus 4x cube as minus 3x cube and minus x cube, correct? Okay. And in the same manner, I am going to write this 2x square plus 4x also. How do I write? Tell me. So you can observe here, I can write this 2x square as plus x square minus x square. So here 3x cube into x minus 1 we will get. So this term is okay. Minus x cube is left now here. And then minus 2x square is also left. Okay. Minus 2 minus x cube minus 2x square plus 4x minus 1. So how do I write? Minus 3x cube minus x cube I have written. And then can I split this as plus x square minus 3x square? So it is to be minus, what do you get? Minus 2x square. Okay. And here in the same manner, I am going to split this as 3x plus x minus 1 is equal to 0. Let me observe now. What do we get? Oh, sorry, what I have written. Here x minus 1, no? Sorry. X power 7 into x minus 1. What I have written? X power 7 into x minus 1. Okay. Minus x power 5 into x minus 1. Yes. Now what do I take? 3x cube I can take common. Okay, very good. And here only x is left and 1 is left, right? Very good. And plus x square, can I take common? If I take plus x square, what is left then? Plus x square if I take, is it minus 3x cube, right? Okay. What do you get actually? Minus plus 4x cube, 3x power 4, up to this 3x power 4 minus 4x cube is minus 3x cube minus x cube I have written. Okay. So 3x cube I took common, x minus 1 is left. Now out of these two, right? So out of these two, what do I take common? Plus x square if I take x minus 1, minus x square I have to take, I think. Right, because minus x cube, x minus 1. If I take minus x square, what do I left? Yeah, minus x square only. My x minus 1 I will get, okay? And then these two are finished. Now 3x. Minus 3x can I take common here? So it is going to be x, and because it is plus, I took minus before. So I will get minus 1. Okay, very good. And plus 1 I can take x minus 1. Okay, any doubt in this? So can I take all terms contain x minus 1? I am taking x minus 1 outside. X power 7 minus x power 5 plus 3x cube minus x square minus 3x plus 1 is equal to 0. What is the meaning? Whenever a two terms a into b is equal to 0 means, what is the meaning? Either a is equal to 0 or b is equal to 0. Okay. In the same sense, x minus 1 is equal to 0 or x power 7 minus x power 5 plus 3x cube minus x square minus 3x plus 1 should be 0. Okay, right. What do I do now? So we got one root now here. You see, x is equal to 1. X is equal to 1 is one root. Okay, because x minus 1 is 0. Then we have to get still how many roots we have to get? 3 roots, right? Why 3 roots? Let me first simplify this also again in the same manner. Because it is x power 7 and x power 5. So can I take x power 5 as common here? X power 5 into x power 2 minus 1. Okay. And here also, can I take x square as common? If I take x square as common, 3x cube. So out of these two I am making as one group, okay? A 3x square I am taking. 3x square if I take 3x, sorry, not 3x, 3x only. If I take 3x only, then x square is left and minus 1 is left. So this is minus x square plus 1 because we want a plus x square. I am taking minus 1 as common. X square minus 1, which is equal to totally 0. So all the terms contain x square minus 1. Yes. Can I take out x square minus 1? Very good. Correct. X square minus 1 into what is left in the first term? X power 5, second term plus 3x minus 1. Okay. So x power 5 plus 3x minus 1 is equal to 0. This we got. Okay. If you see here x square minus 1, a into b again equal to 0, right? So x square minus 1 is equal to 0. X square is equal to 1. So x is equal to plus or minus. Okay. So you got 1, 2, 3 roots. Okay. Right. Then what do I do? X power 5. Let us consider this as f of x. Okay. Because we can't simplify this as we did before. Okay. So let me simplify this x square x power 5 plus 3x minus 1. F of x. Okay. Then generally what we do, we have to differentiate the f of x, no, in order to know the roots. F dash x is equal to what can I get? X power 5 means 5x power 4, 5x power 4 plus 3. Okay. So 5x power 4 plus 3, no? So no doubt it is going to be greater than 0, right? It is greater than 0. So you see the power is here you see the power is odd. Okay. If the power is odd, x power 5 3 plus 3x minus 1, power is odd 5. So what do you say? If the power is odd, then it is going to take limits from minus infinity to plus infinity. It can go very, right? From minus infinity to plus infinity, right? So it can start from minus infinity to plus infinity. Very good. And then, so whenever it is moving from minus infinity to plus infinity, so at any one point, it is going to touch the x-axis, right? No doubt it is touching the x-axis at one point. So it is touching x-axis at how many points it is touching x-axis at one point. Okay, can I go like that? At one point. What do I say from this? Yes, what do I say from this? We have here, it is going to touch the x-axis at any one point. So what do I say from this? It is touching the x-axis. So x is going to be, what are the coordinates can I write? Or otherwise you can go with 5x power 4 plus 3 is equal to 0, no? You can decide like this also. Wait, I will tell you. 5x power 4 is equal to minus 3. Can I go like this? X power 4 is equal to minus 3 by 5, right? You can go in this manner also. So it is imaginary. Am I right? It is imaginary root. Okay? It is an imaginary root. So what are the three different roots we are getting? Actual three different roots are going to be the three different roots. The three different roots. So here also it is touching x-axis. It is touching at x-axis one point. Okay. So it is touching x-axis at one point means you'll get one. What I say? What do you say? One root. Am I right? One root. Okay. So you got totally three distinct roots. What are the three distinct roots we got? One is 1. Okay. And here is again 1. Am I right? Again 1 and minus 1. So this is plus 1 minus 1. Okay. Like this, we are getting all the roots by using this kind of equation. Understood? Very good. So what do you do? Whenever you have this kind of things, you try to split any kind of term into two terms such that you will get the same common factor. And then you simplify, you can easily get it. Okay. Okay, understood? So x-axis at one point means you are getting one root. So instead of calculating this one, you can say you are getting one root. So one root and two roots. Totally three roots. Okay. Yes, correct. Okay then. So let us move to the next question. Here, come on, let us observe the next question. Yes, come on. A point on the parabola y square is equal to 18x, at which the coordinates increases at twice the rate of the axis. How the ordinate is going to increase? So you know ordinate and abscissa. You take x and y. Okay, x is called abscissa and y is called ordinate. Okay, so how these two are increasing? You see, at which the ordinate is increases at the twice rate the abscissa is increasing. So what is the meaning? At what rate it both are increasing? First, let me write the parabola equation. Okay, what is given? Given y square is equal to 18x. Okay, y square is equal to 18x. So can I differentiate with respect to x? Differentiate with respect to x. Very good. Come on, you differentiate 2y into dy by dx is equal to 18. Okay? Any doubt? Very good. Now what you do? Tell me. So 2y into dy by dx is equal to 18. We are differentiating with respect to x. What do I get actually? So can I find dy by dx here? Dy by dx is equal to 18 by 2y. So 2 one time, 2 9 times. So 9 upon y. This is our dy by dx value. Okay, very good. And you observe the question now. According to the question, what is given? How the y coordinate is increasing with respect to 2 times the rate of x coordinate. That is y coordinate rate. So how do you call y coordinate rate? That is dy by dt, right? Dy by dt is equal to the y coordinate, that is ordinate. What is the sentence? You look at this. Ordinate is ordinate increases at twice the rate of abscissa. Ordinate increases twice, 2 times the rate of abscissa. Yes, can I go like this? Very good. 2 into dx by dt. Yes. From this, what can I get? Can I get dy by dx from this? Because dt dt are going to cancel. Yes. If I send dy by dt by dx by dt, dy by dt, dx by dt. So dt dt cancel. You are getting dy by dx. So what do I get? Dy by dx is going to be 2. Okay. Any doubt? Dy by dx is going to be 2. Then what you do now? Tell me. Yes. Dy by dx is equal to 2 means what I am going to write? Dy by dx is 2. So here dy by dx is equal to 9 by y. What is our first equation? Let us take this as equation 1. Then we will substitute in that. 9 by y. Okay. Can I substitute dy by dx as 2? 2 is equal to 9 by y. So 2y is equal to, can I go like 9? Y is equal to 9 upon 2. Yes. So you got ordinate, right? We got ordinate. Let us find the abscissa now. How do I find the abscissa? So in order to find the abscissa, they gave the equation. Okay. Y square is equal to 18x. So simple. You substitute in that and you will get the value of abscissa, right? Any doubt? So simple, isn't it? So 9 by 2 whole square into 18, which is equal to, oh sorry, 1 by 18, no, what I am writing? X is equal to, because I am sending x is equal to 1 by 18, okay? Yes. So this one single 9 and 9 twos are 18 cancel. 1 9 is left, okay? 9 by 4. X is how much? 9 upon 9 one time. 9 by 4, no, sorry, this is, let me write 9 into 9. I will write clearly. Second. So this is going to be 9 by 2 into 9 by 2, okay? 9 one time, 9 two times. So 9 upon 8, okay? 9 upon 8 we got. So what are the required points? The required point is, so first we are writing abscissa, that is 9 upon 8, comma, 9 upon 2. This is the point, okay, which is required with respect to this condition, that is rate of ordinate is increases at which the twice of the abscissa is going to increase for a particular parabola y square is equal to 18x. Understood? Yes, very good. Let us observe the next question. Come on. Yes, you observe this question. Consider a rectangle whose length is increasing at the uniform rate. Whenever you see the word rate, what is the meaning? You keep in mind that with respect to time, that is something by dt. Okay, that quantity, the respective quantity with respect to time. How the quantity is going to increase or decrease or change with respect to time, that can be called as rate. Okay, that is very important. Come on, consider a rectangle whose length is increasing at the uniform rate of 2 meter per second. Breadth is decreasing at the uniform rate of 3 meter per second. Okay, and the area is decreasing at the uniform rate of 5 meter square per second, because area 5 meter square per second. If after some time the breadth of the rectangle is 2 meters, then what will be the length, they are asking. Okay. So how they are changing with respect to time, those are all given here. Okay. How those are changing with respect to time, all are given. What we have to do? When breadth is 2, at that time, what will be the length we have to find? So the question indirectly is saying that when B is something, get the value of L, means you should write the equation in L and B. Understood? Yes? Sure. Very good. Yes. Consider a rectangle whose length is increasing at the uniform rate. So length is increasing at the uniform rate. So can I write that as dl by dt? Okay. Let me write the given. So length B L, comma, breadth breadth B, B, okay, and area B A, okay. If you take all the things as variables of a rectangle, what I can get? Tell me. Here, what is given first? The length is increasing. Increasing means not out positive, right? Always increasing is going to be positive at the rate when you take with respect to time. When it is decreasing, it is going to be negative. The 2 points should be keep in mind. Okay. Yes, very good. Now you see the length of the rectangle is going to increase. So with respect to time, it is changing. So can I go with dl by dt? Very good. So the length is increasing uniformly at the rate 2 meter per second. Okay, it is going to be 2. And what about the decrease in the uniform rate? That is, breadth is decreasing in the uniform rate 3 meter per second. Breadth is going to be decreasing. Okay, no doubt the change is always represented with a small change can be represented with a d with respect to with respect to that quantity to that of the 2 with respect to time. Sorry, d small change in that quantity with respect to the small change in time gives our rate with respect to any quantity. Okay. Yes. Now dB by dt, which is going to be, because it is decreasing, right? So it is decreasing means it is going to be -3, right? Very good. Next, you go for what about the area is decreasing at the uniform rate 5 meter per second square. So can I go with dA by dt? It is going to decrease. So it is going to be -5. Very good. Now, you know because they are saying about area. Can I go with area formula? So area of rectangle. What is area of rectangle? Yes, L into B. A is equal to, you write all letters. All letters are very important. Okay. Yes. So can I differentiate this with respect to T because I know all the things? Yes. So dA by dt. What I am doing? Let me write some voltage. Differentiate with respect to t. Okay, because you will get a big expression. No, this is UV rule we are applying. Okay, so you will get a somewhat big expression. So for that I wrote here. Come on, let me write that. What do I get? Tell me. So this is first. What is u d by dx of uv? Come on, say d by dx of uv is equal to, yes. First you have to keep the u. Any way you can do. Okay. First differentiate the first thing, du by dx into v plus u into dv by dx. So you differentiate one thing and you keep the other thing as it is. You differentiate the next thing. Now you differentiate the next thing and you keep the other thing as it is. Okay. In that manner, we are going to do L and B because this is in the form of UV. Okay. Very good. Let me take that U into B. Come on. Observe. What do we get? U into B. How can I write? L into B. So DL. Can I keep DL by DT into B plus, okay, and then I am differential, I am keeping as it is, and dB by dt. Any doubt? Very good. So dl by dt is 2b. B I am keeping as it is. Plus L into dB by dt is minus 3. Okay. So can I erase minus 3 into dB by dt? Yes, very good. You understood? dB by dt is minus 3. So I substituted all the values. So what do I got? dA by dt is again, can I keep minus 5 here? Because this is also given. Okay. Very good. And now, what do we get? Come on, observe. Oh, sorry, L into what I substituted? 3L, no? What I did? Minus 3 into L, sorry. So you see, dl by dt is 2, no? 2 into B, and L into dB by dt is minus 3. What I did, sorry. Yes, you see, what do I got? Minus 3L minus 5 is equal to minus 3L plus 2B. Okay? Yes. What they asked in the question, come on, observe further. If after some time breadth of the rectangle is 2 meters, so what will be the breadth now? Now when you keep breadth as 2 centimeters, 2 meters, sorry, what will be the length they are asking? Okay, minus 3L plus 2 into breadth is 2 meters. If B is equal to 2, you write. If B is equal to 2, if B is equal to 2, then this will be our expression, okay? Right? So what do I get? Minus 5 is equal to minus 3L plus 4, okay? So minus 3L is equal to, can I go with this minus 4 to minus plus 4 to this end? So it is going to be minus 9 minus 3L. So minus minus cancel. L is 9 by 3. So 3 one time, 3 times. So L is equal to 3 meters. So when breadth is, if breadth is equal to 2, then L is going to be 3 meters. This only they asked, right? Okay. So what do you do? It's simple, so simple, no? What we did? We did simple, whatever the given words we are converting into our, what do you say? In the form of mathematical form like dl by dt, dv by dt, and da by dt, and just we are applying the formula for area of triangle. So simple, okay, and then differentiating and substituting the values, and according to the given condition we are keeping, we will get the other value. Okay, got it? Any doubt? Yes, very good. Let us observe the next question. So this is given in May 12, 2012. Okay, 2012, this one. Okay. Let me say before questions also. So the before question, this question is metallic circular plate. Sorry, not this one. A point parabola question. It is given in 2004. Okay. And this is given in a rectangle. This is 2012, I said. And coordinates, no, this one 2022. So 2022 question paper is somewhat difficult when compared to different years. Most of the people are saying, okay. 2022 uh, question, this one. Okay. That's why they gave this x power 7, and we are splitting all the things, all the concepts are going to apply in that question. Okay, in this, find the identical roots I told no beginning of this video. That is the first question. That is 2022 question. Okay, right. Okay, this is also done. Right. The next question is, sorry, yes. So metallic plate 50 centimeters. Yeah, you observe this now. If a metallic circular plate of radius 50 centimeter is heated, so that its radius increases at the rate of 1 mm per hour, then the rate at which the area of the plate increases. Yes, tell me what you do. Here the metallic plate of radius. Okay, metallic plate of radius. What about the metallic plate of radius? Radius is given as 50 centimeters. Okay, 50 centimeters is heated so that its radius is increasing. Okay, radius is increasing at the rate of 1 mm per meter, 1 mm per hour. Sorry. So here the given is going to be metallic plate radius. Metallic plate 14th question. This one with respect to that solution. Yes, metallic plate radius is equal to 50 centimeters. Okay. So that its radius increases at the rate of 1 mm per hour. So with respect to time, they are saying, right? Okay. So which is R is equal to 50. So the radius is increasing with respect to 1 hour. Every 1 hour, it is going to rise 1 mm. Okay. dr by dt is going to be 1 mm. Any doubt? dr by dt is going to be 1 mm. 1 mm means, can I go with 1 by 10th of a centimeter? Yes, very good. 1 by 10th of centimeter. Okay. Now, what do I do is here, metallic circular plate. This is a circular plate, okay? And radius is given. Very good. Then the rate at which the area, the rate at which area of the plate increases. Plate increases. Increases means you are getting positive. Okay. Right. The rate means with respect to time, how the area is going to increase. That they are asking. Okay. Very good. So area, what is area of a circle? Area of circle is going to be A is equal to pi r square. We know this. Okay. Very good. So can I differentiate, because they are asking the area of plate increases the rate at which. So rate means I'll go with dA by dt. Yes. Differentiate both sides with respect to time. Okay. Pi into, can I write 2r into dr by dt? Okay. Yes, correct. Then what do I get? So dA by dt only we have to calculate the rate at which the area is going to increase with respect to time. Okay. Or centimeter square per hour they are asking. So this is 2 pi r into dr by dt. Okay. Yes. Yes. What do I get now? Tell me. I can write this as, because you see dA by dt is equal to, here you know the value of R and as well as dr by dt. Both are in centimeters only. Both are in same units. So can I substitute directly without hesitation? Very good. Yes, R is going to be 50 and then 1 upon 10. Okay. 0, 0 cancel. So what is left here? 2 pi into 5. Okay. That is 10 pi. 10 pi centimeter square per hour. So dA by dt is 10 pi centimeter square per hour. Understood? So what do you do? Whenever they had given such kind of questions, what do you do? Radius is given and dr by dt, that is rate of change of radius with respect to time, that is dr by dt. Next A, dA by dt, rate of change of area, rate of change of area. Okay, rate of change of area. Small change in area, we can call that as, okay. That is dA by dt. Okay. Generally, the small change we are going to represent with delta, right? A small change. Suppose if initial radius will be R1 and the final radius will be R2. If the final radius is R2, then what is the change in radius means? What do you do? Delta is equal to R2 minus R1, right? Delta is going to be R2 minus R1. A small change. This is a very small, no? So that is can be called as this D instead of what delta, no? This is delta. So D we are taking D. This is also a small change in any quantity with respect to time here because we are talking about rate. Okay, with respect to time only. So if you go for dy by dx, then what do you say? Because any algebraic expression is going to be a function of x, right? Generally, we can go with other variables also, no problem. But generally speaking, any kind of algebraic expression is the function of x. Okay, so y is equal to this function of x can be called as y, correct? Y function of x is called y. Okay. So if you differentiate, because we are differentiating this one, why we are calling always dy by dx, find dy by dx, they'll give something, find dy by dx, find dy by dx, anywhere, okay? Or you can say f dash x, alright? F dash x and dy by dx both are same, okay? Why? Because dy by dx dy by dx is we are finding the change in y with respect to the change in x. Okay, change in y is how much with respect to the change in x. A small change in x, how this is going to affect the change in y, that is called dy by dx. Is it clear? Very good. So now you understood what is the rate, what is dy by dx. That is clear, I am thinking. Yes. Okay. Now let us observe one more important point I want to say. The differentiation also I want to say. Okay. You see here r square. R square if I differentiate. So this is in the form of x power n, right? So you know how to differentiate x power n. How do we differentiate? So if you remember the standard thing, okay, then you can easily solve any kind of question of this form, x power n. So how do you differentiate? D by dx of x power n I am finding. Okay. D by dx of x power n. So what I do? N into x power n minus 1. So here, in the same way, I am taking r square here. Okay. How do I write r square? 2 into, because n is here 2. Okay. 2 into r power 2 minus 1. Yes. 2 into r power 1. So the same thing I have written because before that, any kind of constants are present. You keep the constant as it is. Okay. There is no change. But if you have only constant, say they gave like this, y is equal to sum 2. Okay. Y is equal to 2. I am asking you to find dy by dx. So what do? You are doing change in y. Okay. Change in y with respect to small change in x. Okay. So is there any y or is there any change? Is there any x here to find? Nothing, right? So it knows x is not present. So when you differentiate, that is when you differentiate or when you find the change in y with respect to the change in x, it is going to be 0. Totally. Why? Because we are not finding any kind of x here. If you find x, then you can estimate that, yeah, x is going to change like this. So y value should be like this. We can estimate or we can say, okay. But here we are not finding any kind of x here. But actually, here x power 0 is present. So x, how it is changing with respect to 0? X power 0. So x is not present. So it is going to be totally 0. Got it? Yes. I want to say the differentiation regarding to these. We will observe the differentiation also, the all differentiation formulae and all differentiation, okay, PYQs in one video. Let me observe the, yeah, you see here, y square is equal to 18x. Let me teach you only differentiation for all the problems. What we have done. I forgot about that to say how the differentiation takes place. Okay. Let us observe this. So here you see what I am doing, what I am writing here, differentiate with respect to x. Okay. With respect to x. Right. So if I differentiate with respect to x, what can I write? So I told you already what is the general form. This is the standard form of the. This is the first rule. Okay, we have many different differentiation standard results. Okay, out of this is the first thing. This we are totally using in differentiation x power n because any function you take, it is in the form of x. Okay, so x power x square, x cube, x power n, like that we will get more things, right? So because of that, x power n we are finding. Okay, yes. Let me. So how do you get the x power n? Now can I differentiate this one? Yes, differentiate with respect to what? That is very, very important. X. Okay. With respect to x, I am differentiating. So x power n, y power 2. So here n is 2 and x is y. Okay. Got it? Yes. So 2y into. So what I do, what is x power n? Let me write first x power n is equal to n into x power n minus 1. Right? So 2, whatever the power you have, that times 2 into x. So this y here instead of x, 2 power and 2 minus 1. Any doubt? 2 minus 1. What do I get? What do I get here? 2y. Very good. Okay. But you are not differentiating x. If you differentiate x, so dx by with respect to x, you differentiate, you will get 1, right? Dx by dx. Okay. But here we are differentiating y with respect to x. So no doubt dy by dx. Okay. This is very, very important. Generally students do the mistake here. Okay. So try to keep in mind that. So with respect to what we are differentiating, what do we get here? You try to write that. That is very important. Okay. 2y into dy by dx, which is going to be, because I am differentiating with respect to x, both sides. Okay. Both sides. Come on. If I differentiate both sides, what do I get? So 18, what I said, whenever you have a constant, you keep the constant as it is and you differentiate, yeah, whatever the variables whatever the variables you have, you go with those variables. Yeah, if I differentiate x with respect to x, what I get? It's only 1. Okay. Yes. So what I am getting? Dy by dx is equal to 18 by 2y. Okay. 2 1 time, 2 9 times. So 9 by y we got in the previous question. You check. Okay. Yes. In this manner, we are going to differentiate this question. Got it? Yes. Let us observe the next question. In this directly we are taking, but length and breadth. Yeah. Here those two are very important. Here one more rule is coming in the with respect to the differentiation. So here area is equal to L into B. Only this I am saying. I am not substituting those. Okay. So what I do? L into B, right? So how do you differentiate? Because they are asking what are they asking? Come on, observe. Breadth. If after some time breadth of the rectangle is 2 meters, then find the length. Breadth of the rectangle is, that is, breadth is going to change with respect to time as 2. Okay. No, sorry, not with respect to time. Breadth is changing. So when breadth is 2, then what will be the length they are asking? Okay. But here they gave the rate. Breadth is decreasing at the uniform rate 3 meter per second. Okay. So all are changing and decreasing the uniform rate. Area is also changing. So can I differentiate easily with respect to time? Differentiate with respect to x. Oh, sorry, with respect to t. See now, I also got now x. Generally, we differentiate with respect to x. Okay. But here, whenever you observe the rate, okay, generally in these applications of derivatives, rate is very important. That's why we are differentiating with respect to t. Okay, very good. So dA by dt is equal to, if I differentiate, what I am doing? I am differentiating A. I am differentiating A with respect to time. That is d by dt of A. What is the meaning actually? Let me write. I am differentiating with respect to time. Which quantity? A quantity. Okay. So A quantity I am going to differentiate. That's why I am writing dA by dt. Okay. Why I have this? You understood? Yes. Come on, let us observe. So dA by dt is equal to, okay, dA by dt is equal to, how do you I write this one? Because you see, dA by dt is going to be, how do I differentiate this? This is, here we have two variables. What are our two variables we have? Here, the two variables are L and B, okay? L and B are our two variables. I want to differentiate. But what is the operation they are doing? They are doing the operation. They are doing the operation that is multiplication. Okay. They are multiplying. Very good. What are they doing? They are multiplying. Okay. So what do I do? L into B, no? So whenever you have two variables, U and B, let us take. Okay. If you take y is equal to u and b, okay, so I am differentiating with respect to x. So what I do, differentiate both sides with respect to d by dx of y. Okay, I am finding, yes, what you do, so because two variables when they are multiplying with each other, you keep the first variable as it is and you differentiate the second variable. Anyway you can do, you first differentiate the first variable and keep the second variable as it is. That is your wish. So because why? Because addition is commutative. Okay. Yes. So now I am different because I differentiate v here. Now I am keeping v as it is and I am differentiating u. Any doubt? So you differentiate one time and you keep the other thing as it is, like that you differentiate. Okay, so this is the ub rule. Okay, so actual ub rule, u into v, whenever you have u into v, so du by dv into v plus u into dv by dt. Understood? dv by dt, this is the rule you have to remember. That is, whenever you want to differentiate two quantities, two things, okay, two variables, okay, at a time, they are their product, that is multiplication of different multiplication here. Okay, whenever a multiplicants, two multiplicants, you, if you want to differentiate, you go in this manner. Understood? So dA by dt is equal to, how do you write this, tell me? So can I write L as it is? Okay, L as it is, I am going to differentiate the second one first, and next I am keeping B as it is. I am differentiating the first one. Okay. Now, after writing this, then the total problem is going to be easy because we know dL by dt and dB by dt and dA by dt. Just substitute it and get the expression. Get the expression, and when B is equal to 2, the condition is given, and get the value of L. Okay. Got it? Very good. Yes. Okay. Suppose when you have a division, let me take u by v. Okay. Whenever they have u by v, I will do one video of all this, but just I'm explaining the two things, u and v, u by v, only two things. Those two are very important. Wherever you find in these kind of problems, you will get it. Okay. U by v. So for u by v, rule is going to be, so first you make the denominator to be whole square. Okay, v square. Then what you do is v into du by dx. Okay, minus, next v dv by dx into u. Okay, that is v square is in the form, v square is here, v into u dash minus u into v dash. Okay, got it?
v square du by dv. U v dash, because I took here du by dx and u dash. Okay. And the dv by dx is v dash. Generally, it is a function of x, so I took here d by dx. Okay. Or v into u dash minus v dash into u by v square. Okay. Understood? In this manner, we are going to differentiate. Okay. V square v into du by dx minus v dash into u. Okay. Very good. Yes. So then other thing, because whenever you have addition and subtraction, say x square plus x cube, if you want to differentiate, you go directly, because here because there is no rule for addition. Directly you separately you can differentiate. That is here x square. That is, I told x power n is n into x power n minus 1. Okay. That is 2 into x power 2 minus 1 plus 3 into x power 3 minus 1. So 2x plus 3x square. Okay. In this manner, you can easily do separate things, either plus or minus. And I told multiplication, UV rule. Okay. And then I told for division rule, U by V. Okay. You do in the same manner. Okay. Got it? Yes. Very good. Next, you see, I think we observed all differentiation. Let me check. So this differentiation also we observed. Okay. And then y square is equal to 18x. And then here, the area at which the plate increases, okay, dA by dt. dA by dt, A is equal to metallic plate, pi r square, no? Yeah, we observed at the beginning only this one, metallic circular plate. Okay, yes, we observed all. So let us continue this kind of PYQs in the next video. Okay, please like, share, and subscribe. Thank you.